Hello, everyone, and welcome back to our new session of the TechTalks series. Today, we are excited to present a session called Two Examples of FDM Technical Filaments Used in Industry. Our speaker today is Girek Aleph from Nanovia. Welcome.
Hello, everyone.
He is materials engineer specialized in additive manufacturing and business development. He has extensive experience working with advanced materials for 3D printing. Today he will be presenting these two key categories of technical filaments. The first one is magnetically detectable and food contact certificate filaments and fire-resistant filaments. Surely these two materials offer unique properties that are essential in our industry. So we will go in deep about these two different kind of material. Just a couple of reminders before we start the webinar. So first of all, we will have a Q&A session at the end of the webinar. So we will have 5 minutes to reply to everyone's questions. You will find a tab in the upper corner where you can write your questions during the webinar. If we are unable to reply to everyone's question, we will reply later on via email, or you can contact us directly. Thanks again for joining us, and let's give a warm welcome to Girek. I'll hand the stage over to you.
Okay, thanks for the presentation. I will share my screen up. Okay. Okay, let's go. Yeah, thanks for the presentation. To start, I would like to give you a quick introduction to the company, Nanovia. We are based in Brittany, on the West Coast, under England. And what we do at Nanovia, we develop and produce some thermoplastic materials for additive manufacturing. We have an expertise in composite materials. All of our production and development is internalized. For this, we have a R&D team with materials and chemical engineer. And to make and develop our products, we have our own compounding and manufacturing production lines. We also have a printer farm, which allow us to print small to mid-sized batch production. We have around 15 3D printer, a few classic 3D printer, but also a few technical 3D printer with a heat and enclosed chamber to print technical filament. And we work in two sections. First, we work in B2C with a national and international distributor network. And on the other side, we work in B2B. For example, a customer comes to us with a specific requirements to develop a new filament. For example, he wants a filament with glass fiber, with a specific fiber weight and specific color. So at Nanovia, we are able to respond to this kind of request thanks to our production capacity. So we offer functional materials responding to industrial needs. We work with sectors as aerospace, naval, medical, and construction. And for the story, we have some Nanovia filaments in the International Space Station and in military submarines. We now come to the subject of the day, which is a presentation of two technical filaments used in industry. First, I'm going to present the Nanovia food industry. I will talk about the certification, the magnetically detectable, how does it work, what type of parts, then the kind of performance, and I will finish with the printing parameter. And then the second part will be focused on the Nanovia fire-resistant filament. I will show you the different standards, first the UL 94 standard, and then the EN 45 545 standard. And I will finish with the printing parameter. Okay, the polyamide food industry is a filament we launched last year, and we launched it because we had a lot of demand for materials that could be used in the food industry. All materials can be used in this industry because there are some standards to respect to guarantee the food safety. For example, there are the certification food contact. There are two main certifications. There is an American one and an European one. And the purpose of this two standard is just to ensure food safety. For example, the European standard specifies the requirement, which must be respect for any plastic materials that comes into contact with food. But what does it mean? It means, for example, no migration of new substance on contact, doesn't affect color, smell, or taste, or again, no absorbent, corrosion, resistant, and durable. And the conformity with this standard is declared in a document called Declaration of Conformity. And this document is supplied by the manufacturer, distributor, or importer. And everyone has to provide this document to their customer. For example, if Nanovia prints a part in these materials for a customer, we will give them this document. We also have other food contact filaments, such as PLE, PETG, ABS, and HIPS. PLE, PETG, and ABS are very well-known filaments in 3D printing. HIPS a bit less. HIPS can be used to print impact-resistant parts, but can also be used in other support material. But why I'm only talking about PA food industry today, it's because this filament has something more compared with this filament. And what is it? This filament is not only food contact, he is also magnetically detectable. And how does it work? The polyamide-based filament is mixed with a lubricant and metallic charge. And the metal charge triggers metal detectors on food production lines, which avoid broken parts into final products. And what kind of part we can print with this filament? It could be blowers, spatula, some templates, gear, or again, some food processing machinery parts. And thanks to the polyamide matrix, this filament has a few interesting property, like mechanical property, chemical resistance, or again, easy sterilization, because it's essential in the food sector to prevent bacterial contamination and guarantee hygiene. Then on the bottom right, you can see a few technical data. We did tensile test on 5 test samples print with this filament. And to ensure the repeatability, we print this assemble under the same condition, using the same printing parameter and the same printer. The tests are print in the direction of the stress, which means at 0 degrees. And taking the average of the 5, we got some mechanical data. For example, the Young's modulus, which means if the material is more or less rigid. Here, the Young's modulus is 3,800 megapascal. So it means that it's a quite a rigid material. And also we have the max tensile strength, which is the limit before the materials breaks. So for this filament, the max tensile strength is 83 megapascal, which is pretty high for a 3D filament. And to finish on this filament, I'm gonna to give you some advice to print correctly this material. We recommend an extrusion temperature between 260 and 290 degrees, depending on the printing speed, because the faster you print and the higher is the extrusion temperature. Then you have to heat the bed at around 80 degrees. If there is a bit of warping, you can use brims or raft or glues for polyamide. There is no need for heated enclosure. However, for large parts, heat enclosure may be used to prevent some warping or delamination. For the print speed, it will be around 70 millimeter per second. You can print faster, but you will need to change other parameters like the temperature or the flow rate. And we recommend a low fan speed, often below 40%, to ensure a good interlayer adhesion. Then we recommend a minimum nozzle diameter of 0.4 millimeter. Below 0.4 millimeter, there may be some clogging because there are metallic charge in the filament. You can use any type of nozzle. And yeah, the final point, I would like to focus your attention to this last point. It's very important to respect the drying of the materials before printing. Drying eliminates the moisture present in the materials, and this ensures optimum print quality. I remember, for example, we have had some feedback from customers who were not satisfied with these materials. They told me that they had a lot of stringing and poor surface finishes. And when I asked them if they dry the filament before printing, they said no. So I then told them to do another test with a drying filament, and they come back to me saying that yes, the print quality was totally better. So yeah, it's very important to dry the filament before printing. That's it for the printing parameter and the first part. If you have any question, you can ask me at the end. The second part is focused on the fire-resistant filament. Nanovia offers several fire-resistant filaments on different thermoplastic matrices, such as polyamide, polycarbonate, TPU, and ABS. But what is a fire-resistant product and which sector are target? We use this kind of filament in aerospace, railway, and naval, especially for submarine. And why we use them, it's just because fire-resistant parts are used to protect passengers from fires that could happen in trains, aircraft, or submarine. For example, if there is a fire, the parts won't burn and won't emit toxic fume. So it's just a question of safety. And today, this is the three sector of activity are demanding more and more fire-resistant parts for their transport. Several standards have been established to respond to this demand. There are two main types of standards, the UL94 and the EN 45545-2. One of the most widely recognized standards is the UL94. This is a flammability standard for plastic materials used in various equipment and application. UL94 is a material combustion test and can be an horizontal test, UL94HB, or a vertical test UL94V, V0, V1, or V2. In both tests, an open flame is applied to the sample for a time. The test determines the material's behavior in suppressing or propagating the flame. The material is classified according to HB, V2, V1, or V0. For example, V2, the combustion stops within 60 seconds with drips, which is not very good. For the UL94 V1, the combustion stops within 60 seconds as well, but there is no drips. And to finish, the UL94 V0, the combustion stops within 10 seconds and there is no drips, which is definitely better than V1 or V2. So a material V0 is considered to be more fire resistant than a material UL94 V2, for example. So when you are looking for a fire-resistant filament, pay close attention to the different levels, V2, V1, or V0. To finish on this standard, there is an important point to know, which is the thickness of the printed part. Each fire-resistant material has a minimum thickness for obtaining the UL94 V0 standard. This information is indicated on the UL card, also known as the yellow card. For example, the PCIBS V0 must have a minimum thickness of 0.4 millimeter, and the PC V0 needs a minimum thickness of 3 millimeter. So it's very important to pay attention to this because when you are printing parts with thin walls, you need to make sure that the PCV0 is at least 3 millimeter thick. And why I'm telling you this, it's because in 3D printing, we often use a perimeter of 2 loops, which is often 1.2 millimeter with a 0.6 millimeter nozzle. So be careful with the PCV0 because you will need to modify the geometry of the part to obtain the walls always at least 3 millimeter thick. On the photo on the right, we can see a part print in PCIBS V0 with a thin wall of 2.22 millimeter, which is good because it's higher than 0.4 millimeter. If it was below 0.4 millimeter, we couldn't certify the print part. Other example, the part print in PAI has a wall higher than 0.4 millimeter, so it's good for the V0 standard. So yeah, just careful with the thickness with the standard. Okay, now it's the standard EN 45542. It's an European railway standard published in 2013 to harmonize the various train management system, including fire and smoke standard. This standard is more strict than the UL94 standard. Compared to the UL94 standard, we can add a self-extinguishing property, no release of smoke, and no toxic material. All materials used in the manufacture of rail vehicles must comply with the standard to have the highest possible level of safety. The products are then classified according to a set of 26 requirements, R1 to R26. It depends on where the materials will be used for a particular level of hazard. Nanovia filaments are suitable for R22 and 23 requirements, which are for inside seals, coils, inductor, box, or contacts. And the final point to know about this standard is the railway vehicle are classified according to the level of fire risk linked with their design and operation. There are three fire risk levels, HL1, HL2, and HL3. HL1 being the lowest requirement and HL3 is the highest. For example, if we take a conventional train that is above ground with a good evacuation, the risk level is HL1. On the other hand, if you take a double-decker train with beds and this train is underground, the risk level could be HL3. And parts print with Nanovia PCABS-RY and PRA have a risk level HL1, 2, and 3. And yeah, here it's just an example for the PCABS-RY, which have the UL V0 standard and the EN 45542 standard. And this filament combines the mechanical and thermal properties of PC with the printability of ABS. And here on the bottom left, we can see 3 burn samples just after UL 94 V0 test. The sample are printed with native ABS, PC ABS V0, and PC ABS high. The samples are 10 mm wide and 3 mm thick. And what can we see after 10 seconds exposure to the flame? You can see that the native ABS has burnt, is still burning, and is giving toxic fumes. Then the PC ABS V0 has burnt a bit, but no longer burns and gives no smoke. And finally, the PC ABS-RY is self-extinguishing. It doesn't burn and there are no toxic fumes. So this test confirms the level of the standard. So it's easy to see why the rail industry is demanding more and more materials with fire-resistant performance. And yeah, I will finish with the printing parameter. I'm not going to list all the printing parameter one by one, but the main thing to remember is that most of this technical filament need enclosed and heat printer, except for the Flex V0 and PRI. PCABS V0 can also be printed without enclosure, but it's better to have one to limit warping and to obtain a good interlayer adhesion. We advise a low fast spin. You can even turn off. Lowering the fan speed will reduce warping, but it's not the case for the Flex V0. And be careful not to print Flex V0 too faster because it's a flexible filament, so a direct drive extruder is definitely better. Pay attention to the diameter and type of nozzle for the PRI and PCABS-RY because this is filament on metal and ceramic particles. So we advised reinforced nozzles with a minimum diameter to avoid nozzle clogging. And to finish, I told you the last thing and maybe one of the most important thing is the drying of the filament before printing. You really have to respect the drying time and temperature. This is directly affect the print quality. So if you don't dry them, there is moisture in the filament and the print quality is poor. So yeah, just careful with this point. and I think it's finished. I think I have talked about everything, and if you have any question, don't hesitate to ask me.
So we already have some questions. I don't know if you want to read them first and then you can reply.
The first question is, can you tell which are the HDT for the V0 and rail filament? For the HDT, it's not in the technical data, but I could send you the HDT by email because I don't have this information just now. Alors, another question, with the UL94 and 545, do you certify the part or the filament? It's the filament, but we can certify the part because I told you we have a document which is the declaration of the conformity. So it's the same question. In other terms, if we have a production of parts for the railway, do we need to certify to AN 545 each single part, or the filament certification is sufficient to cover them all? That we did it for a batch, if it's the same part, for example, if we have to print 20 parts, just one certification is enough. But if the part is different, it's not the same part, we have to have a certification on one part and the second part. How many times it's possible to sterilize the component produced with the food contact filament? Honestly, we didn't test about the sterilized filament, but it's important to clean the print part to ensure the property of the filament.
So we have a couple more, and if you can see them.
Yeah, I'm not sure I understand the last question. In addition to the certification on materials, have you ever received a request for process certification? For the process, if we have the good material, for example, the polyamide rail, we print the part with this filament. After we check the geometry, the thickness of the walls, and we will send the declaration of the conformity to the customer, and it's enough.
We receive another one, I don't know this one with them.
Yeah, just okay. Yeah, for the question, can the printing process compromise the food contact application even if the material is certified? No. If you have a classic 3D printer or a technical 3D printer, it's the same. If you have the good filament, no worries. It not depends of the 3D printer and not the strategy of how you print 0 degrees, 90 degrees. No.
Okay, so I think that's all. We don't have any more questions. They're on the chat. If you have any question later on, you can write us down to our email, and then we will put you in contact with Direct so we can reply further.
Yeah, and if someone wants the presentation, no worries, I could send the presentation.
Okay, so thank you very much, Greg, for being here today. It was really interesting. Thanks to everyone who joined today. We remind you that we will have another webinar next Wednesday. So if you're interested, please join again.